All right, hello everyone. Welcome to another lecture video for CPSC 1012. In this video, we're going to be looking at creating user-defined objects that we could use in our own solutions. So the objectives for the lesson will be to define a class. So we'll talk about how to do that, how to implement the encapsulation of our member variables, which we'll see is kind of done by default, kind of as a good best practice, but we'll look at that together. We'll then instantiate objects from our class and talk about how we can use those objects to develop a full-on solution. So let's get it. All right. So the problem set that I'm looking at here for today's lecture is the object problems PDF that you can find on the Moodle site for the course. In this case, we're presented with a question, one, which is to define a class, and then question two, which is to then use that class to develop a full-out solution. What I'm going to do with you in this video is not build out the entire solution. It follows a pattern that we've already seen in previous exercise problems and assignments. So I'm going to leave that to you. But what I will do with you in this video is show you how to define the class, some of the nuances we'll talk about with encapsulation and properties versus getters and setters. And then I'll also show you how to instantiate objects of a particular type. And then, in question two, it says, hey, create an array to store these student objects. I'll show you how to create that array so that you can use that to build out the full out solution. And then I may have a couple of supplemental videos that cover some other areas and concepts related to object-oriented programming, but I want to keep this one a bit short and sweet and to the point so that you can get on with developing your exercise problems and then the final assignment when that becomes available. So just looking at this quickly, we've got a class diagram here that's pretty straightforward. We've got our identity, so the name of the class is student. We've got our state. We've got three member variables that are defined here. So we have a first name, last name, and an ID number, types for those variables, and then the dash here indicates that these should be private. So these are going to be internal only variables accessible to the object itself and not directly accessible to the outside world, as it were. And then below, we can see we've got a number of methods that are available for the class. The visibility modifier here is a plus. So these are public. So that indicates that these methods are all available to the outside world to call on the object to ask it to do particular actions. The first two are unique in that they are constructor functions. So the first is our default constructor. So we'll talk about how to build that and to use it to create a student object that has kind of good, sane default values for the properties, the first name, last name, and the ID number. And then we've also got here a constructor, or what some people would refer to as a greedy constructor, that accepts parameters for all of the state member variables so that we can set those values when we create the object itself. So one thing we'll also look at is it doesn't state here that there are any business rules that we should implement. So for example, there's nothing here that says the first name and last name cannot be empty, or that the ID number must be a 6-digit number. There's nothing like that. So we're kind of left to our own devices there to figure things out. But I will show you how we can apply the properties and talk a little bit about throwing exceptions and using that to ensure that the object remains in a valid state. So we'll look at that even though it's not documented here in the question set. And yeah, as far as the methods go, they're pretty straightforward. They're basically getter and setters for all of the state member variables that we have. And then there's also a final method here called getFullName, which just simply returns the last name and the first name in this fashion. So last name, comma, first name. It's not explicitly required in question two, but we can test that and see how that works. So this question number one, I'll implement this with you, and then like I said, I'll show you how to get started on solving the problem here for question number two, but I'll leave the majority of that implementation for you to do on your own. So again, no real plan is required since we already have the class diagram. We can just begin a new project and then begin to define this class. So I'm going to create a new project here. Again, it's a console application. I'm going to create this as lesson 7 objects. And away we go. All right. So again, we get our basic scaffold for the program. So one thing that I want to point out here, and now we can start to talk about kind of the fuller code that's included in this scaffold, is on line 5, we can see there's a statement here that says class program. And so now we have some language and some idea about what that means. So again, this is not new. We're going to be talking about defining our own classes, but we've really been defining a class in every single program that we've created to this point. And the class, for lack of a better word for identity, has been called program. And that class has had our main method, which has been the insertion point for all of the programs that we've created to this point. Now, again, it's a static method, which means we don't have to instantiate a program object in order to call it, which makes a lot of sense. You can't instantiate a new object from a program that isn't already running. So that's the mechanism that's used to fire up the program itself. And then, like we said before, we were creating additional methods inside the class scope that were also static so that we never had to instantiate an object of this particular type. And so that's one way to make use of classes. And we've seen classes used in that way. So, for example, we've used the math class and methods that are available on that particular class, static methods. So those aren't new. We've used them already as built-ins as part of C#. But now we're going to be looking at creating our own discrete, unique, user-defined objects. But the pattern is much the same. We define a class, and then we define methods inside that class. The differences are going to be, of course, that instance methods do not have the static keyword, and that we're also going to be defining member variables, which won't be defined inside of a method. They'll be defined inside of the class scope. But outside of those two differences, you already know everything you need to know in order to create classes and then instantiate objects of those class types and then use them. So everything hopefully will feel familiar once we get to it. So to define our student class, we want to create that in the same namespace. Now you'll notice that this is currently a file called program.cs, and one possibility for creating our new student class would be to actually create it in its own separate file. So that's possible too. So if you were to go to your file menu, you could choose to create a new file. And then you can choose what type of file you want to create. So it could be a resource file, et cetera, et cetera. There's different kinds. And you can create a class file if you want. So for example, here under general, there's empty class. We could do that. You could give the class its name, and then you would have student.cs. And that's fine. But to keep things simple, for this course and for the management of submission of assignments, etc., I'm just going to define the class that we're going to use inside this same namespace. So we're only going to have the one file. It will still work as expected, but it's going to make it a bit simpler, I think, for everyone, so that you don't have to worry about managing these files outside. So in short, if you do create your class as a separate file and figure out how to use it that way, that's totally fine. But if you create your class the way I'm going to show you, which is just inside the existing program CS namespace, that is totally fine too. So we begin by, again, outside of the class program, we're going to create our new class here. We use the class keyword identifier, and we're going to create the identifier student. And that's it. We've created a new class. There isn't really much more to it. It's kind of anticlimactic, but that's how we define a class. And so from here now we can go about implementing the additional pieces, so our state and our behaviors, should there be any. So again, from the lesson notes, you may have state or behavior or both. There's no mandate to have both. In this example we do, but sometimes there's not a need to have one or the other. So we'll define our three state member variables first. So first name, last name, which are both strings, and then ID number. And one of the kind of accepted practices for naming member variables so that they're easily identifiable within the class is to prefix them with an underscore. So we can define, and we'll explicitly mark these as private. So we'll have private string underscore first name. We'll have private, string underscore last name. And we'll have finally a private int underscore ID. Okay, and we could do the ID first. It doesn't matter. Ordering is kind of irrelevant, but that's fine. So now we've got a class with private encapsulated member variables. And these member variables are not going to be accessible because of the private visibility specifier that we have here. So at this point, we can already start testing this class to see how it's going to work. If we go back into the main method of our program class, we can update this. Let's just get rid of the console write line. We can now define types of, variables of type student. So we can say, I want a student variable. We'll just call it student. And left alone, like I have here, all we've defined is a student variable that can refer to a student object. Okay, so classes are abstract reference types, just like arrays. So an array variable name points to or references an actual array that exists somewhere in memory. And that is exactly the same way that these class or student objects are going to work as well. So this student right now doesn't point to anything. It doesn't refer to an actual student object. But the only thing that it can refer to is a student object. But it doesn't actually store the student values in the reference itself. Okay, it refers to another location somewhere where those values can be found. So if we were to actually instantiate an actual new student object, we use the new keyword, and then we can specify the default constructor. So again, you'll notice here we haven't defined student as a method on the class, and yet we're able to call this here. And that's because every class by default will have a constructor that is the name of the class with an empty parameter list. So you'll never be able to create a class that you can't instantiate from, at least not by default. And so at this stage, when this statement executes, the right side of the assignment operation here will create a new student object that has memory allocated for storing, a string first name, a string last name, and an integer ID. And we've assigned a reference called student that kind of points to where that object is, if that makes sense. And so now we could, try to do things with that student object. So if on the next line we try to access, with the dot property, different pieces that are inside, we'll notice that nothing comes up, right? So there's some by default methods that get inherited from, just a generic object class, but there's no underscore first name. So if we try to type that out here, and we try to say something like the first name is, we'll just go with the first name is Jane, we get an error here. It won't even compile, and it tells us this represents text. That's not what I care about. Right? It's string. Student first name is inaccessible due to its protection level. Okay, so it knows that there's a first name member variable, but we cannot directly access it, and that is because of this visibility specifier here, private. If we were to change that, for example, to public, you'll notice that now all of a sudden that red squiggly line goes away. It's recognized as a field of the student object, and it's a string, and now we can freely go ahead and directly access that property, okay? Which, again, is not always bad. Sometimes it's fine. If you don't have any business rules that you want to enforce on the value for this field, then you could just make them all public and just basically what you have is a struct. You have an object that has a couple of variables in it. They're grouped together nicely. So even without doing anything with methods, this is already giving us a nice means of packaging multiple variables of different types together and having a single reference that we can use to refer to them. So if you recall from the previous lesson about arrays, if we had, let's say, a student's first name and last name and their ID, and we wanted to have those related, we would create 3 individual arrays, one for student first names, one for last names, and another array for IDs, and then we would have them associate across, or there'd be like parallel arrays. So the value in index 0 of the first name array corresponds to the element in index 0 of the last name array, which also corresponds to the element in index 0 of the ID array. So you would have 3 different arrays you would have to go visit to get the information for one single student. And now by being able to create this abstract student type, right, as a class, we're able to take those 3 values that should be grouped together and actually group them inside of a single reference. So that alone is a huge benefit for grouping multiple variables in this idea of objects. And it makes it much easier to work with things like that in your program. And so at this point, if we wanted to have a list or an array of students, we would no longer need to create 3 independent arrays and then manage them, we would just create an array that can hold student references. And then we could just create new students and assign those new students to elements in the array. So it's going to help us save a lot of time and help us to organize our code in a much more efficient and maintainable ways. But this is not what we want to do. We don't want to be able to directly access. I do want the default private specifier here, so that this is not going to be possible. And so then we're forced to think of ways in which we can access the first name to set it. And now we've got really one of two options. We can use a method to do this, or we could use a property. We could also use a constructor method to do that straight away as well. But I'll show you first of all how we could do this with getter and setter methods, and talk about when you would want to use either one, and then we'll implement with properties as well. So we'll just leave it here for now, that's fine. So down below in our student class, to create the access for these variables, we can go ahead and create public methods that can now be called on the student object to refer to these internal private member variables. So for example, if we wanted to give a user access to assign a value to the first name, we would need to create a method that accepts the incoming value and then assigns it to that member variable. So we could create something like public. It won't return anything. We'll call it set first name, and the parameter it accepts will just be, whatever. I'll just call it first name. So it takes in a first name value that the user is hoping that they can assign to it. And so then what we need to do inside this method is reference our member variable underscore first name. Right? So this is how we can differentiate between parameters that are coming into a method that perhaps may share the same name as our member variables. Underscore first name is clearly not the parameter first name. If you go online and you do a search, you might see code that makes use of the keyword this. So you might see something like that. And this is just a reserved keyword that refers to an instance or an object if and when it would be instantiated. So I've found that often confuses students, at least up front when we start beginning to work with objects. So decided to forego that. But if you do some reading and you understand how this keyword works and you want to use that, that's fine by me. It's not required, but you're not going to get in trouble or something if you do happen to use that. So we've got unique names, so that's fine. So underscore first name is going to be assigned whatever value was passed in for this first name parameter. And so now we don't need to do that. What we need to do is call our set first name method, and we can pass that value in. So we create a new student object in our program, and then on that new student, we call the set first name method, and we pass in the value that we would like the object to take and then set. And so what that enables now is the ability for this object, right now we're just blindly assigning it. So it, for example, would be possible to do something like this, where we can say, hey, set the first name to an empty string. And there are no conditional checks or anything like that. So when this method gets called, it's just going to take this value and assign it, no questions asked. But what we do gain is the ability now within this method to actually ask questions and enforce any business rules should we wish to. So if we did want to enforce the rule that the first name cannot be empty, right? It cannot be an empty string. Now, rather than just blindly assigning this parameter to our local member variable, we can first ask some questions. So we might do something like the following. We would say something like, only do this if the first name, when trimmed, so we'll trim white space off the end and the beginning. If we trim it, and the length is not equal to 0. Okay, so if we trim it and it doesn't have a 0 length, that means there are actually characters in it. Then we want to assign the value. And so now if we we don't really have much here as far as the program goes, but if we try to run this and see what happens. Oh, this isn't going to do anything. It's just going to exit that method. If we try to set that here, let's try something else. And then we'll do a console dot write line. we want to get access to that first name. So if we want to be able to set the first name and we want to be able to display it, we need access to be able to do that too. So we've got a check here now that will only assign this value if it's good. I'm just going to put a breakpoint here so we can see this in action. But if we execute this, and then when we break, if we have a look at our student object, we can see how that's going to look in code. So we have a first name, an ID, and a last name. And you'll notice here that the first name value is null, which clearly indicates that we did not assign it this empty string value, right? Empty string is not the same as null. Clearly, our conditional check has worked. So if we stop that and then we run it again where we actually do pass in a good value, assuming my conditional check has been typed out properly, if we go and look at our student, now we can see that the first name actually has a value of Jane. Okay, so that's what we gain by encapsulating our member variables, right? So they're not free to the outside world here, wherever we create an object, to be accessed and perhaps assigned invalid values. By wrapping them up in these methods, we now have control over any kind of business logic that we want to apply to ensure that we only ever assign good known values or values that we think are a valid state. And yeah, it's good to have control to do that. Now, that's just one piece of it. So right now, if we do call this method and pass an empty string, there's nothing that indicates that something has gone wrong. And so, again, this is kind of like a back and forth, I don't want to say an argument, but it's more of a discussion as to what is the best practice for dealing with things of this nature. But one mechanism for dealing with attempts to assign invalid state values is to throw an exception from within the method. And then that not only enforces the business rule, but forces the calling method. So in this case, our main method, it would force the main method to actually have to deal with the fact that may throw an exception. So we could say something like what we have here, only if the first name is, has a non-zero length do we do this. And if that's not true, then what we can do is we can use our keyword throw to create a new exception object. And hopefully, just even given the discussion we've had so far, you recognize that what's happening here on this line, we're indicating that we'd like to throw an exception, and specifically, we're creating a new exception. And hopefully, you can see the similarity between what is happening up here on line 9 and what we now have on line 30. So on line 9, we are creating a new student object, and if you would guess that, well, are we creating a new exception object here on line 30? The answer is yes. That's exactly what's happening. So exception, again, is a class. We are calling the constructor to create a new exception object. And then one thing we can do with it is we can also create a message that will be displayed if and when this exception ever occurs. So we could do something like, first name cannot be empty. Okay. And so... And so if we run this code again, now because we're setting or sending in an empty string, this will not be true. So we should see that this exception gets thrown, and I would expect that this message then will be displayed. So when we do a try catch and we access the exception object's message property, that's what this string will end up being here. So let's just run this quickly now again. I don't have any breakpoints in it, but we should see an exception occur. So there it is. Right, we have our system.exception has been thrown, and here's our message. So the first name cannot be empty. And so if we don't want our program to crash, at this point now, we're going to have to deal with that in the calling method. So we could wrap this up into a try catch. So we could say try to do the following, okay? And so we could do a catch. And just to show you how the message works, we can catch exception E. And so now in the catch block, we can access this message from the exception object. So we could do something like console.writeLine, and we can, we'll just dress it up a little bit. So we'll say something like there was an error, and then we can display e.message. Okay, and remember that e.message is going to be the string that we passed into the constructor method here for the exception object we created. And so now our program will crash. It's not going to do anything amazing, but at least it won't crash. We should see that on the console. We get that error message now. So here we go. There was an error. First name cannot be empty. So this is implementation. An implementation of the throw early and catch late. So again, if there's a problem here with the value coming in, we don't want to deal with it here. We don't want to have the console write this string from within the class because we don't know. The class definition doesn't say anything about how it's being used. So maybe we're using the student class to create objects in a Windows application where there is no console. Okay, and in that environment, it makes no sense to write a message to the console because like the user's not going to see that. It doesn't exist. Or maybe instead of displaying error messages to the screen, we want to write them into an error log file, into some kind of a text file so that we can review for error messages later. Well, if we just have a console.writeLine statement here, there's no way to ever get those error messages written to a file. So we don't ever want to catch exceptions and deal with our own exceptions inside the class. We want to throw those exceptions out of the class and then again force any calling methods like we have here, the main, to try and catch. And so now I'm free to deal with that exception in whatever way I want. I can write it to the console, or I could display it in a pop-up window if we had a Windows application, or I could write it to a log file. I'm free to do what I need to do as part of my application with the exception message. The class doesn't do that for me. So that's something that we try to implement when we develop our classes as well, as this throw early and catch late principle. Okay, so far so good. We've defined a class. We only have a single method. We have no way of getting the value yet. So let's update that. And then I'll show you how to implement the same getter/setters with properties, and then we'll put them into an array. So let's go back and revisit our student class. The next method we want to implement is a means to access the first name. So this method lets us set it, but we can't access it to display it. So if I wanted to write here on this line 20 the first name to the screen, I can't. There's no way to access it to do that. Again, because it's private, we need to specify also a method, not just for setting, but one for getting. Okay, and these are commonly referred to as getter and setter methods. So in this example, again, it's going to be public, but the first name is a string type, so the return type is string, and we'll just call it get first name. Okay, there are no parameters that need to be passed in, and all this is going to do is return underscore first name so that we can read it. Okay, so getter methods are pretty generic. They don't do a lot. There's no reason to really implement any logic here. We just take that value and return it so the user can access it. So then now on line 20, if we want to see that, we can call the get first name method, which will retrieve the inside, the member variable, and pass that to us so that we can now write it to the console. So as far as defining a class goes, I mean, this really does show all the basics. We could write getter and setter methods for the remaining two member variables and then put some comments on the methods, and effectively it's done. Okay, so again, there's nothing really new that you don't already know to implement classes. There are variables and there are methods. We already know both of those. Inside the methods, we may have control structures like if else or for loops or while loops, conditions, everything that you already know. And like I mentioned earlier, you've already been working within classes and creating methods inside classes. So we're just taking it to another level where instead of just working inside the scaffolded program class, we're now able to create additional classes of our own choosing. So our user-defined classes that we can use to represent abstract types in our solutions. So now if we run this program, let's stop that. I want to pass in a good value. So let's pass in a good value now. We'll say Jane. So we shouldn't catch an exception. I shouldn't see this error message. I should just see Jane echoed back into my terminal. And so there it is. So the output is Jane. Hooray, there we go. That's that. We've got an object that we can work with. Okay. So let's just stop there, and rather than implement the getter and setter methods for the remaining member variables, I'm going to just kind of do away with this and show you how we can do the same thing by using C# properties, okay? So it's not every language supports this idea of like properties. If you were moving to Java or something else, you might still be stuck with just this idea of getter and setter methods, which is why I want to show you how to implement them and talk about why they're important. But C#, part of the language also supports this idea of properties, which makes working with member variables like what we have here a little bit simpler than defining these two unique getter and setter methods for every single member variable. So they're very commonly used. So properties help us wrap that up. So rather than having a separate set and get method, we can define properties very simply. Okay, so those are just defined directly within the class, and typically they map onto the member variable name, but they follow the same type of method naming convention that we see here. So like this idea of like title casing, first capitalized letter versus lowercase first letter with camel casing. So we could define something like public string first name, and then we can do something like the following, and then have get and set. Okay, and I just want to put the scaffold in for it so we can compare it quickly to what we had already done with our getter and setter methods. So there we go. So if you look below here where we had our set and get methods, you'll notice here that the property kind of mirrors that very closely. Okay, we don't have unique names, so get and set are generic, but we do have a unique property name. So this property now can be used to both get or retrieve the first name value and also to set it, versus having two independent methods to do the same thing. So the get method is going to effectively do exactly what our get first name method does here. So the get part of the property, we can just pop that in there. And then the set is going to do whatever we had done in the setter method. So again, it's not that there's any additional work. It's the same amount of work. It's just a different way to package it up, if you will. So we'll take this and we'll dump that in there too. Okay. Oops. And so now I can get rid of my get and set methods. And so what we've done here is update our class to, instead of using getter and setter methods for first name, to use a property. Now you'll notice here that there's a first name that's referenced still from the previous method we had. That doesn't exist. And you'll also notice that there's no like parentheses here. So set is not like a method call. So when we're dealing with properties, we have to take advantage of a keyword called value. Okay, and value is a keyword that represents the value that would have been assigned to the property. Okay, so again, this is just something that you have to know. It's the way that properties work. You have to just know that within the set piece of a property, there is a value keyword that we can use to represent the value that's being assigned to the property itself. So once we make those two changes, all the errors go away. The rest of it all stays the same. And now to update where we're using the set and get methods, we just now implement our property. So instead of saying, set first name, we can treat first name like a variable, and we could just use the assignment operator. So now it looks like student.firstname is assigned Jane. So again, very similar to syntax you've already used, where we assign values to variables. So now we can use that same type of syntax with our property for the first name. And then the same is also true for the first name when we want to retrieve it. When there's no assignment being done, just referencing the first name property will enact the get accessor for the first name property. And when we have an assignment operator for the property, that will access the mutator or the set piece of the property. So that's how that works. This implementation, like I mentioned, is identical to the getter setters, except for how we kind of put it into action. Again, for me, I don't have a preference for one or the other. I think you'll find working with the properties maybe is a little bit cleaner, because we have all of the get and set for any particular property wrapped up in one scope, which is kind of nice versus having two methods. But if that seems kind of confusing and you like the idea of getter and setter methods and you want to implement them that way, for me, that's fine. Again, the course is about programming fundamentals. It's not about C# per se. So use whatever mechanism makes the most sense for you. Okay, but that's how that works. And so, yeah, we can go about putting comments on these things. So you can put a summary on for the first name. Represents something like the first name of a student or for a student. And that's it. So now we can both get and set, right? And when you look here, you can see when we hover over it that it has both get and set options, right? Represents the first name for a student. So, and that would be fine for me. I would be okay with that. Make sure you put the comment on it, define it. We have meaningful names on things, so the code is for the most part self-documenting. You might put a comment in here to describe the business rules. So, for example, instead of do not, we'll just say something like only allow non-empty values. Okay, so that's what we're checking for. Oh, the non-empty values. Okay, great. Otherwise, we throw an exception. Fantastic. Okay, and that's it. And then the same thing is true for our class student. We could put a summary on here, for example, that this represents a student. That's what it does. There's nothing really else to kind of say about that. So now when we have our student, we can see that here it represents a student. And then when we access our properties, we get the unique comments that we've defined for those as well. And so then you would just repeat that. One thing I do want to show here is the implementation of methods that are not tied to member variables. So for example, we have a method here, get full name, which again should return the last name, comma, first name. And then some of you might look at this and say, well, there is no member variable for full name. And that's fine. We can define any number of methods on the class. So, right, you're not limited to defining methods that only are gets and sets for these state properties. We can define methods to do whatever we want. It's just that we also happen to define the methods for these so that we can access or mutate them. So in this example, to get the full name, there's no set for that, right? And we can see that clearly within the class diagram. But there is a means to call a method and then get the last name and the first name returned, formatted, like we see here. And so we could easily implement something like this for the last name as well. Again, I'm kind of lazy, so I'm just going to copy and paste this wholesale and say we'll have the same rules applied for our last name. So once we copy and paste, we can say here I've got my last name for a student. You'll see there's an error because you cannot have a duplicate property. So last name, and then here as well, you could do refactor and rename, but I'll just type it out because it's not too much. Okay, so last name returns, last name gets set, and then we can say the same thing here, that the last name cannot be empty. And so, spell that right. So now we have a last name property and a first name property. So let's try to update this a little bit. So we'll set the first name, but we'll also set the last name. Okay, so we can access our new last name property. So first name is assigned Jane. Oops. And the last name is assigned Dope. So that's totally fine. Everything's great there. And now here on line 21, instead of just writing the first name, I want to make use of this full name property. So we could define that as a method, but we could also define it as a property as well. So we could try something like the following. So let's do public. Again, it's a string. Oops. And I'm going to call this, full name. And we can define a get. And you'll see everything's kind of fine there. We don't have to define a set. That's totally fine. And now we can return, and I'll just use an interpolated string to make life a bit easier. We return the last name, comma, the first name. Okay, and that's it, right? So there's no set. There's no full name member variable to set. So we just exclude it. We say, this is basically a read-only property. And you'll notice here in the pop-up, it shows there's only a get for this. Okay, unlike the first name and last name properties that have gets and sets, this one only has a get. That's the only way that it can be used. And so we can say here too, returns the student's full name, and then we can show it, it's like whatever, last name, first name, whatever. It's a comment that describes what it does. And so now that we have that as a property, we can go back up to our main, and instead of displaying, student of first name, we can access full name. Okay, and again, no problem there. We see our comment here. There's a get only, so we can use it in this way. If we try to do something like student dot full name is assigned something, right, you'll notice here it tells us the property or index or student full name cannot be assigned to. It is read only, and that is because we have not defined a set mutator for that property. Okay, so you get to choose either a set or a get or both. You don't have to include both, and they don't have to be tied to member variables. I mean, in this example, it is again, but even, you could have a method or a property that, doesn't have anything to do with any of these and just does something else. That's totally fine. You can define the method in whatever way, shape, or form makes sense for your program. So now that we have those two pieces, we can run this again, and I would expect to see now Doe, Jane, because of the full name property that we're displaying here on this line. So there it is. There is. Oops. Why can't I get rid of this? It's kind of messy. Doe, Jane. So because of the full name property here. Right. So working with objects allows us to really organize our code in ways that make sense. We can talk about students and we can talk about their first names and last names, but now we can also model students within our code. And once we've modeled a class for a student, creating a student and then using that student in our code is pretty straightforward and makes a lot of sense, right? Oh, this student has a first name and a last name. And of course, we're not limited to only creating a single student. There's nothing preventing us from doing something like, having student 1 and student 2. And so now, I could be explicit to say this is student 1 that I'm setting the first name and last name for, but we can create as many objects or instances of any particular class as we need for our application. Okay, so your assignment, for example, that you'll be tasked with will require you to create many different objects that you'll need to store. Much in the way that, question 2 of this problem set says, hey, create a program that allows you to store up to 25 students. Okay, so we can create as many objects as we like. The class just defines the type. It doesn't say how many how many instances of that type you could have. You can have as many as you want. So that's kind of it as far as working with objects go. I know it's maybe seeming like, oh, we're going to get into object-oriented programming. It's going to be amazing, but mind you, we're not covering all of the principles of object-oriented programming here either. We're really just talking about encapsulation. We're not talking about abstraction or inheritance or polymorphism, but those are all important. But for this course, just being able to understand, the basics of defining classes and instantiating objects and the reason why encapsulation is good. If all you leave this course with are those ideas and you understand them well, then you're in a good place going forward for the next level of programming in DMIT. So the final thing that I wanted to show you with this example, I'll leave the ID for you to implement on your own. It's very similar. I've shown you how to do the first name. The last name was a copy paste, and I've also shown you how to do the full name. So I'll leave the ID for you. I've also shown you up here how you can create new student objects and trying and catching and dealing with them that way, and also how to use the properties. So there's two final things that I want to show you, and that is dealing with the constructor. So we have a default, but we're also shown here that we need to include this kind of greedy constructor. So we'll look at that a little bit. And then also for question 2, how would we define an array and store student objects in the array. And that's actually pretty straightforward. We'll do that last. So let's just go back down here and revisit our class for a moment. And I'll just do this between our member variables and our properties. We can define a public student method, okay? And so a constructor is a little bit different than the other methods that we might define on a class. So if nothing is jumping out at you, the one thing that should is presently there's no real issues, first of all, with this definition, but also that we're missing something that we've typically seen with all the other methods so far, and that is a return type. So student, capital S student, which matches the class name, is public, so it can be called from the outside, but it doesn't have an explicit return type. Okay, and that is because it is identified as a constructor for the class, and therefore the return type is implicit, right? It's implied that the student constructor will return a student type object, right? It would be redundant to do something like, this student constructor returns a student. Well, I get it. So, you don't have to do that, okay? It's implied that creating the student constructor returns it. And so what we've done here is we've overridden the default constructor. There already was one, right? We know that because we were already calling it. What I'm doing now is I'm overriding that method to do whatever I want. And so since the default doesn't accept any parameters, what we can do here, like we kind of briefly saw at the beginning, was we can assign these member variables kind of like safe or known initial values. So rather than having like null for our strings, maybe we do assign them empty string values. Instead of a 0 or something for our int ID, maybe we assign it a default like 9999 or something like that. Okay, we're free to assign known values to our member variables. So we could do something like first name, right, is just an empty string, and our last name is also an empty string, and finally our ID, let's just assign it -1. Maybe that's to indicate that, hey, this isn't a valid student object. And then again, we can put our little summary on, and we can say default constructor for student, and we can say here it initializes member variables to safe values. Okay, and then maybe we're explicit and we say here, for example, first name, last name, and ID. Okay, so now when we create our students, we can see that it's accessing our defined default constructor. So it's still a default constructor, but it's not the one that we didn't define. It's the one that we've created. And so if we were to go in and inspect or put a line break or a breakpoint and inspect one of these student references, we'd see that those initial values are the ones that we want. So the second thing we'll do is, so student 1 is fine. We've created using the default, and then we're assigning the values explicitly here. But let's create an additional student constructor that we can use to define the student right when we create it. Okay, so this is what we call method overloading. The method is the same, right? It's still called capital S student, but the signature is going to be different. So if you call student and you don't pass anything in, you'll be calling this version of it. But if you do call student, so public student, and we'll define parameters here, if you call it in this way, then the second overloaded version of the method will be called. So we can define that it gets called with a first name, a last name, and int ID. And in here, now we can do the assignment. So we could do something like first name is assigned first name. Now, and then et cetera. We could do underscore last name as last name and ID. But now one thing that we lose out on doing it in this way is the first name, if we try to call the constructor and pass in a first name value that's empty, well, this will just assign that empty string value, okay? And now is where you'll get into an argument maybe where you say, well, if the default assign it to an empty string, what's wrong with, using the greedy constructor to assign it an empty string? And I'm not here to tell you that's a bad thing. You could do that or not do it. It's fine. Okay, or we could try to take advantage of the property. So if you had set methods, you could call those below, or you could do something like first name is assigned first name, something like that. So again, here, this is utilizing the property that we've created earlier, and we're saying, hey, take that first name property and try to assign it this value. And one of the benefits of doing it this way is any logic that we've implemented on the set, like we have here, will now be applied when we try to create the object. So I don't have to copy and paste this code to check the incoming first name parameter for the constructor. I can just say, hey, I already have a property that checks that before it assigns it. So why don't we just use it? And we can do the same thing. So last name, same thing, will be assigned this incoming last name parameter. And I don't have a property for the ID, but the to-do would be implement the ID property. Okay. So what I'm stressing here is that we can take advantage of existing code, right? Again, one of the benefits of modularization of our programs is code reuse. And we can say, well, in addition to creating the object and having the property to assign values, we can take those properties and we can still use them even when we try to create an object of that type to ensure that we have the same business logic applied to those values when we try to create them. So now we have two versions of this constructor. Okay, so again, like we said before, this is what I'll call constructor for student. What do I say here? It accepts all properties, okay, or all fields, or all member variables, what do you want to say? And first name, so here you can say the student first name, the student last name, and the student ID. Okay, and fantastic. And so now we've got two constructors, right? We've got two means of creating these student objects. And so up here, we can see this is using the default. Now when we hover over the method, you'll see that +1 overload. So you would have seen that before. For example, if you look at WriteLine, you'll notice here there are 17 overloads. And that, again, is because the WriteLine method has been defined to accept a string, but there's also another definition where it accepts an int, and another one where it accepts a double. And each one of those method declarations is different. It's the same name, but it's been overloaded based on the different parameter lists that have been defined for each one of the function declarations or the method declarations. So we've got that now too. So student 2, what we can do here is we can say, well, let's not use the default. Let's use our new one. So we can create, first name, Sally, last name, whatever, Ann, and then we specify an ID. Doesn't really matter, okay? And so now the first student is being created using our default constructor, and our second student is being created using our greedy constructor. And so now we can display the second one. So let's display student 1, but also display student 2. Okay, and then you could dress those up with interpolated strings. Student number 1 is and whatever, but this gets the point across. Okay, so if we run our program again, now we should see we got two students. One that we explicitly assign the values for. Oops, what is... Oh, man, sometimes this terminal now is just kind of dying on me, which isn't really great. There we go. There they are. Okay, so Doe Jane and then Ann Sally. So we're seeing that both of these student 1, student 2 full name properties are working. We created our objects in two different ways. One, using the default constructor, and then we had to explicitly assign values. And then another one where we're doing it this way. Now, note, of course, that because the student the greedy constructor here is using the properties of first name and last name inside, it could still throw an exception. So really we should be wrapping this in a try catch as well, because if we try to do something like this, that's going to cause an exception to occur where it's going to say the first name cannot be empty. So be aware of that. If you are throwing exceptions from in your code like we're doing here and here, you'll want to make sure that anywhere that could be could happen, you're going to want to test for that and make sure that you try and catch so that your program doesn't crash. Okay, it's very important. It's easy to overlook, but try your best to create test plans that test for those scenarios. Okay, the final thing here now is, we've got student 1 and student 2, but what if we were storing these in an array? And this part is actually really straightforward. So rather than defining individual variables like we've done in the past where we had, ints, for example, or strings, if we wanted to create arrays for those types, we just simply add brackets to the type. And this is no different. So we can define the student type with brackets. And you'll notice it already tries to pluralize it as students. And so now I've created an array reference that can reference an array of student references. It's absolutely no different than what we've seen already. So then we can initialize it. We could create a new student array, and the problem we're tasked with says we should be able to hold a maximum of 25 students. So now I've created a new student array, right, that has enough room to hold 25 student references. And so instead of defining student 1 and student 2, we could just put these new students directly into our array. So for example, students at index 0 and students at index 1. And so now we can reference those student objects from within our array. Okay, this isn't obviously best practice. I'm just demonstrating how we can use arrays. You would want to have like an index value, and you'll probably loop through them, etc. But this just demonstrates that it's no different than what we've seen working with arrays of other types. So instead of int or string or double, you just simply say, well, hey, I've got an abstract type called called student. So I want an array of that type. So you just define the type and put the brackets, and there you go. So now I've got a 25 student array, and I can assign new student objects to elements in the array. We can access them, right? It's absolutely no different. So if you've done the practice exercises and you've done the work learning how to work with arrays, and all that makes sense to you, the next step now is to just apply all that same logic but with different element types. So again, instead of having elements that are strings or doubles or ints, now your elements are simply students. But like I said, this is a huge benefit because previously we would have an array of string called first names, and we would have an array of string called last names, and we'd have an array of int called IDs, and we would have 3 parallel arrays where we would have the first name and the last name and the ID for one student in 3 different arrays. Now we have take the example of a second student. I've got those 3 values grouped together in one location, right? If I want the second student's first name, last name, and ID, I just go to the student's array and find the second student. And now I've got all their information. The methods on the object I can call. I don't have to keep track of what index in the array I'm at to make sure I get the proper corresponding values from other arrays. It's all just in this one reference, which is really nice. Okay, again, that's one of the major benefits of grouping and organizing our code using objects. So we get away from having to manage large numbers of parallel or corresponding arrays. So that's kind of that, right? With this information that I've shown you here, you should be able to go ahead and complete this this program. Okay, so the next steps are to add a menu, have some program logic to allow the user to choose from a menu whether they want to enter a student's information, or they want to view this report, or they want to quit the program. It's pretty simple. Okay, I've shown you here how you would be able to assign values. So you could create a student object and then prompt the user for the first name, last name, and ID and assign them like we have here. Or maybe you prompt the user for the first name, last name, and ID, and then you just try to create the student in one shot and put them in the array. Okay, so there are, like I've shown you here, there are 2 options for creating new student objects. And again, I'm not here to tell you which one is better. I don't think either is better. In either case, you're going to have to ask the user for these 3 values. So whether you ask for them and assign them at the same time, or you ask for them, make sure they're good, and then just create a student once, is entirely up to you. But both of those are valid options that you could apply to your solution. So give that a shot. if you work on this problem and you have any questions, you can let me know or let your instructor know, and we'll be able to give you a hand working through it. I would strongly encourage you to get through this practice exercise. It'll be hugely beneficial for the assignment. There's also a second and perhaps even third object problem sets for you to work on. And again, I would say work on those, practice up, learn how to use objects, and you'll be well prepared for the final assignment and moving on with programming in the next upcoming courses. So that's it for this lesson. I hope you found it useful. Like I said, if you have any questions, let me know or your instructor know. We'll catch you next time.